0.25 minus by 1/8 multiply by half. Close bracket. It looks a bit messy, but let's see whether the answer is correct or my workings are correct. 9 times by 96.656 power minus 3. This is 195.312 times 10 to the power minus 3 plus 2.5 minus by 1/8 minus by 1/8 is equal to 2.25 multiplied by 1/8 multiplied by 1/8 times 1/2. 1.25 minus 1/16 is 1.1875. Let me see again. 1.25 minus 1/8 times by 1/2. 1.1875. We have 182.5 minus by 1/8 minus by 1/8. Yep, 2 points. So this will be equal to 195.312 times 10 to the power minus 3 plus 2.25 times 1/8 times by 1.1875 is equal to 333.984 times 10 to the power minus 3. Let me check again. 1.1875 times by 1/8 times by 2.25. My calculator got error. Times by 1/8 times by 2.25 is equal to 0.33984. So 195.312 plus by 333.984 is equal to 529.296 times 10 to the power minus 3 inches cubed. 529.296. Okay, so if we go back, I don't know what they get. They get 529.29. So it's the same. Yes? Okay. Now the thing to watch for is this. Okay, the thing. So we found that our shear stress is at D. Okay. So the next one is at point E. Right. So where we stop is up to here. We stop up to here. Right. So at point E, Q at point E is equal to 529.296 times 10 to the power minus 3 plus the width is 1/8. Now the depth is 1.25 minus by 1/8, right? So the other 1.25 minus, so then you have again 1.25 minus by 1/8 multiplied by half. Because this is the width, this is the depth, and this is the y bar. This whole term over here is the y bar. So this is equal to 529.296 times 10 to the power minus 3 plus 1.25 minus 1/8, 1.25 minus 1/8 squared. 1.25 minus 1/8 equal first squared times by 0.5 times by 1/8 is equal to 79.102 times 10 to the power minus 3. So this is equal to 529.296 power minus 3 power minus 3 plus y 79.102 power minus 3 is equal to 608.398 times 10 to the power minus 3 inches cubed. Okay, 608.398. So we look over here, 608.39. They just say 0.39. Okay, so we are about the same. We are the same. Okay, so that is your answer for question number what? For this question. Anyone, any thing that you are not sure? You're okay?
Sir, one question. So as
yes.
So this whole question was based on a white flange, right?
Say it again.
This question was based on a white flange analysis, not the thin section, right?
This is still thin wall.
But we did use a white flange analysis, right?
Can you say again? You are breaking up.
wide flange analysis.
Yes, all these are wide
So
flange analysis.
so I have this one question. When we are sure when there is a wide flange analysis, like what we have to see, I'm just got confused in that
Okay,
area.
why is it wide flange? You're asking me why is it wide flange, right?
Yes, yes, sir, yes, sir.
Because you have two terminal. Terminal 1,
Okay,
terminal 2.
okay,
If you look at any wide flange analysis, like the theory when we teach,
yes, sir.
right? You
Yeah,
have two terminal. Terminal 1, terminal 2.
okay, okay.
Make sense?
Yes, sir, yes, sir. It does make sense.
Don't call me sir, call me Eugene. I'm not a sir, okay?
Okay, Eugene, thank you.
Right?
Yeah.
Right? That's why it is what? Wide flange. Okay?
Okay. Yeah,
Now
thank
let's
you.
look at the next question. Okay? The student want to look at the next one. Okay? So where is the next one? Okay, next I think is the question directly below. Okay. Very interesting question. I like this question because this question, I give this question to regular engineering student. They also have the same question. Okay, let's look at this question now. And then you just follow the rules, okay? I'm going to insert a new page. Okay. We have a few of this. So this is our P09. Okay. Then I'm going to also copy the answer. Okay. I'm just going to do the Q because the Q is the one that is the difficult one. Okay. So I will leave this here. Okay. So we are going to design the shear flow again. Okay. So the web, the continuous web determine how the flow should look like. The continuous. So continuous means stop. So now this is the one that control. Okay. Then you do the rest. So if I were to draw the centroid, right? So now we have the terminal is here above the centroid, and below the centroid there's another terminal. So now there's only two terminal, right? The one before we have four terminals. Okay. So this becomes like box beam, yes or no? Because once in this region over here, okay, I'm going to highlight at this region over here, right? And I'm just going to look above the centroid. The Q splits. So this question is a bit tricky. Okay, what do I mean by a bit tricky? I'll show you now. Okay, so I'll show you especially at point D. Is it 1Q or 2Q? Right? Okay, so at point E. So shear stress at point E is equal to 0, right? The Q at point E is equal to 0, and it's at the terminal. At the terminal, the shear stress is equal to what? 0. Right? You got no first moment of area at all. Right? Now, let's look at point D now. Right? Point D from the terminal, right, is coming out, is only having 1 Q. It's not equal to what? 2Q. Right? If you see from the terminal going to point D is just what? 1Q. Yes or no? Okay, so it's just Q. Okay, so over here we know that we are going to find the first moment of area at point D. The width is equal to 1 over 8. The depth is 1.25 minus by 1 over 8, right? And this will be equal to 1.25 minus by 1 over 8 times by half. Now, some of you, Eugene, you did not include the depth, the gap. I don't know what's the gap value. Okay, so I just ignore it. Okay, so now this will be equal to 1 over 8, 1.25 minus by 1 over 8 squared times by 0.5 times by 1 over 8 is equal to 79.10102 times 10 to the power 3 inches cubed. Okay, so which is about the same, exactly the same like what they have. Okay, so now I'm going to find the shear stress at point D. Right, so the shear stress at point D is V over I. Right, the Q is 79.102 times 10 to the power 3. Divide by the thickness, I only take once, 1 over 8. Okay, so what is the V value? Do we did they give the V value? Wait, let me check. The V value is, knowing that the maximum, so I don't know what is the V value. Oh, the V value is 2. Okay, 2 times 10 to the power 3, and I did not find IYY. Okay, so 2 times 10 to the power 3 divide by the I is equal to 1.23812. 1.23812 multiplied by 79.102 times 10 to the power 3 divide by 1 over 8. Okay, so this is equal to 2 power 3 times by 79.102 power 3 divided by 1.23818 divided by 1 over 8. The answer is 1. Did I do something wrong? No, I think this one should be minus. My apology. Times 10 to the power minus 3. Likewise, times 10 to the power minus 3. Okay, so 2 power 3 times by 9.102 power minus 3 divided by 1.23818 divided by 1 over 8 is equal to 1.002 or 022 times 10 to the power 3 psi. Okay, so if we were to look at the solution, 1.002 at point D is exactly the same. It's down here. Okay, the value is down here. It's the same. Okay, now the tricky part is at point C. Okay, at point C. Why is it tricky at point C? Okay, so if you look at point C, right, the area to consider now is this area. Right, the area to consider now is this whole area over here. Right, but we know at point C, one Q go to the right hand side, the other Q go into the left hand side. So when that's the case, at point C is a what? Box beam analysis. Right? It splits. So when it split now, we have what? 2Q. Yes.